The resistance is changing in our circuit, and we need to find how current responds to these changes. Ohm's law is still our friend here. Current equals voltage divided by resistance. We're going to use it to compute the resulting current values. So resistance equals 1 ohm. So current equals voltage divided by resistance. We get 10 amps, which equals 10,000 milliamps. We're converting to milliamps because we're going to need these values when plotting our results. So when resistance equals 10 ohms, current equals 10 volts divided by 10 ohms, which equals 1 amp, which equals 1,000 milliamps. We keep doing this. We have our current values now, and it's time to plot. So the axis here is for resistance. This one is for current. So when resistance equals 1 ohm, current equals 10,000 milliamps. So we have this resulting point. Somewhere here. When resistance equals 10 ohms, we have 1,000 milliamps. So 10 corresponds to a point here. And we keep doing this as we have all our points, and if we are to plot a graph, it should be something like this. And you see that as resistance increases, current is decreasing. This is Ohm's law. How do you increase or decrease resistance in a real-world circuit? You use a rheostat. A rheostat is a resistor with 3 terminals, like we see here, A, B, C. But B, the terminal B, is not static. It can move. And when you're using it in your circuit, you connect your circuit to 2 terminals. Let's say you connect these two, BC, to an ammeter somewhere. And you read your values on the screen here. When you move B to the left, resistance increases. You move it to the right, resistance decreases. You can see that you can use it in your circuit to achieve variable resistance. This one here can change between 0 ohm to 1 kilo ohm. 1 kilo ohm is 1,000 ohms. We have the symbol for a rheostat here, and this is an image of a real-world rheostat. You can see the 3 terminals for a rheostat here. Relate the 2 circuits in the figure below. Where is the ground in the circuit on the right? On the left, we have a schematic for our circuit. On the right, we have circuit components connected together. Our resistor in the schematic corresponds to the resistor. The voltage source relates to the voltage source here. What we need to see is the ground. What is the ground? The ground is the reference point for voltages. So if we say that this voltage source has 12 volts, we are saying that this point here is 12 volts higher than this point. So we are referring to this point for voltages. And we get to recap. Look at this guy. I love his teeth. Let's give him a beard. I've got a beard. Okay, we recap. Ohm's law says current equals voltage divided by resistance. You can use Ohm's law to compute voltage or resistance if you want, and you can use graphs to describe behaviors you find in circuits. I hope this has been informative to you, and I'd like to thank you for viewing.